Hello and welcome to today's class. Today we are looking at another aspect of calculus, and that will be the implicit functions. In my previous class, I have given lessons on functions, and this is just an extension of the function of function principle. Here is what you need to know: that if you can clearly express a function like this, let's say x squared minus 5 given in terms of y, we say this is what? An explicit function. This is an explicit function. Okay, that means you can clearly separate y to the right, to the left hand side. But if you have another situation such that that may not be possible, you can you can separate y totally to be on its own, then we said that becomes what? An implicit function. For example, you have x squared plus y squared to be equals to 5. This is a typical example of what? An implicit function. It means that this y contains a what? Contains functions of x, and altogether this is an entire what? Is an entire function. So what are we going to do here? It is simple to differentiate it. It's just the same way you've differentiated an explicit function like this. So we are going to apply the same method here. To differentiate it, what are you going to do? If we are to find dy over dx, all right? So you differentiate both sides with respect to x. This one will give us 2x. But here, just like you would differentiate this one to give you 2x, this will be 2y. However, because it is y, that is, it is like it is having a function of x in it, you are going to put the derivative coefficient right there, just as if you have y equals to x squared minus 5. By the time you differentiate this, you shall have dy over dx. That is what this one implies. This dy over dx is the coefficient of the coefficient of the derivative coefficient that you must attach to this when you are differentiating it, and this will be 0 because it is a constant. And here you would have 2y dy over dx, and then move this one move it to the other side. That will be minus 2x, and then your dy over dx would be minus 2x over 2y, and that will simply be minus x over y. And that gives you the answer to the question. All right, so whenever you are differentiating an implicit function, always keep this in mind. This is not a partial, it's not the partial differentiation. You differentiate the y also with respect to x, but then you keep the coefficient of derivative. All right, this is an implicit function right here, and we are meant to find the y dx. Remember, implicit function is a function that you can clearly separate the variable y to the left hand side. When you have an attachment like this, we say it is what? An implicit function. So here I'm going to differentiate. That's my solution. Differentiate both sides with respect to x. That is this particular one. This one will become 2y dy over dx. Always keep the coefficient of the derivative coefficient right there. And then this one, like a product rule, we want to differentiate these two things. What are you going to do right here? You keep this one constant. You don't touch this one, but you differentiate this. If you differentiate it, you will have dy over dx and multiply by this, like your u dv over dx, and then plus This one, this time around, you don't differentiate this one. You keep it constant, but you differentiate this. Derivative of x is 1. So this one will be 1 times y. That will be y. That gives you the derivative of the product of xy. And this will be x dy over dx plus y. And if you differentiate a constant, that will be 0. Look at this. We have common terms here. So what you do is that you collect these two, you factorize these two terms. That will be dy over dx. This will be 2y plus x equals to, plus y equals to 0. There you go. And so the next thing to do is to tidy up your work. And this, if you move this like this, that will be 2y plus x dy over dx. And this will be minus y. Hence, your dy over dx, you divide both sides by this here. That will be minus y over 2y plus x. And that is, hello and welcome to this aspect again. That is the implicit function. And here we are in lesson 4. And this is the question before us. The question reads us, if x squared plus y squared minus 2x minus 6y plus 5 equals to 0, evaluate dy dx when x equals to 3 and y equals to 2. If you have been following the video and you think you could work this, you can pause the video and try the answer. Try it and see if your answer corresponds with mine. So here is the working on the board. This is the function that we have. We have to get dy dx, and they give us this boundary when x is 3, and they give us this initial condition when x is equal to 3 and y equals to 2. So from what we have here, solution. If you differentiate through by x with respect to x, you are going to have 2x plus 2y dy over dx. This belongs to this minus 2. This is the derivative of 2x minus 6 dy over dx. This derivative of 6y, and then this will go to 0. Everything equals 0. Okay. The next thing is that you want to collect terms together. This will be 2y dy over dx minus 6 dy over dx. Then I'm going to move this other one to the other side. So I'm going to have 2 minus 2x. 2 will go to the other side. This 2x will also go to the other side. That's what we have. If I divide through by 2, divide through by 2. So I'm going to have y, and I'm also doing something. I'm factorizing. This will be left with y minus 3 dy over dx, and this will be equals to 1 minus x, such that your dy over dx will be 1 minus x over y minus 3. Okay, now they gave us this boundary. These conditions at 3, 2, that is when x is 3, y is 2. That's the coordinate given. Our dy over dx will be equals to 1 minus 3 over 2 minus 3, and this will be minus 2 over minus 1, and this will eventually be 2. So our answer to this question is going to be 2. That will be all for this aspect, implicit function. And the question before us is, if y squared minus 2xy minus 8 equals to 0, find dy dx. Let's get to it. Now we have solution. What we are going to do, we have this y squared minus 2xy minus 8 equals to 0. You would differentiate both sides all through by with respect to x. That's what you're doing. So if we differentiate this one, this will be 2y dy over dx minus this, treat it as a product. Using the product rule, you have 2xy right here. You keep this one, you keep this constant and differentiate this. That will be 2x dy over dx plus you keep this one this time around, this variable x constant, and then you keep this y constant and derive this. The derivative of x is 1, so this will be 2y, just 2y, because 2y times 1 is 2y. So this will be 2y right here, and then bring it here. That will be into bracket 2x dy over dx plus 2y. And if you differentiate a constant, that will be 0, and this is equals to 0. You don't actually need this, just to show what we are doing right there. Here you can just ignore the 0, and then this will become 2x dy over dx minus 2y, and that is equals to 0. Okay, we open the bracket. Now you can collect, these two terms look alike, so you factorize them. Here we have dy over dx. Let me put it this way: 2y minus 2x. And then you have dy over dx, and to the other side we shall have just 2y. Here our dy over dx would be 2y over 2y minus 2x. Clearly you can divide through the numerator and denominator by 2. So this will be dy over dx, and that will be what? That will be y over y minus x. So that is our answer. Thank you.